Good morning, ChemComm. Today we are proceeding forward. The last time we were together, we talked about petrochemicals and how we have, over time, over the last 200 years, we've taken the products of petroleum and crude oil and we've started to manipulate them and create synthetic structures and synthetic substances like nylon and polyester by taking monomers and chaining them together into polymers. Today and the next time we see each other, we're going to get more into the different types of naming for different types of alkanes or petroleum products. Okay, at this point in time, all we've learned is alkanes: butane, pentane, hexane. But there's a world beyond that. Some of these things will sound familiar to you and some of them won't. But you will have, just to help you keep it all, there's going to be a lot of names, okay? But the best part is, to keep it all straight, we give you a chart that basically walks you through how to name everything. And as long as you're good at using the chart, people usually do pretty well with this information, okay? So let's start here today with 14.3, Beyond Alkanes. See what we got. So the first thing we need to talk about is the difference between saturated and unsaturated. The best thing to do here is use a sponge analogy. A saturated sponge is full. It cannot hold any more. And then an unsaturated sponge would be able to hold more water. The way we apply this to hydrocarbons is we think about how many hydrogens a hydrocarbon can hold. So with this hydrocarbon here, there is nowhere else for a hydrogen to bond to, and therefore we would call this saturated. But if you notice, if we add double and triple bonds, so let's say we put a double bond between these two carbons. So now, theoretically, we could break this bond and we could add two more hydrogens. So anything with a double or triple bond we call unsaturated because there's more hydrogen that could theoretically fit there. And this is exactly what I just drew for you. Saturated would be no double bonds, only single bonds. And unsaturated, you would have double bonds or triple bonds present that could be broken to add hydrogen. Here's another example. These are long chains, more of a polymer here. Saturated, unsaturated. Typically, and we'll get to this, unsaturated things, when you have a double bond like that, typically they'll bend if they're long polymer chains. Okay, that can give us different properties that we may be looking for. All right, so now let's talk about what would happen if how would we name it if we have a double or triple bond? Well, if we had a double bond, all right, that means less hydrogen can fit. Because remember, carbon can only make 4 bonds. 1, 2, 3, 4. So this would be a structure, but it's not an alkane. Okay, if this is an alkane, we'd call it ethane, but it's not ethane because of the double bond. The way we deal with this is very similar though. We use the same prefix system. Guess what the suffix is? Well, these are called alkenes, so this is no longer ethane, it is ethene because of the double bond. Alkenes simply just have a double bond present. Notice the general formula is a little different too. The number of carbons and the number of hydrogens will always be double that. If you remember from alkanes, the number of hydrogens was 2n plus 2. But we've put the double bond in, which reduces the amount of hydrogen, which means the formula is a little different. The way we name these, we went through the basics already. You count the number of carbons, you determine the prefix, eth, prop, but, pent, hex, okay? And then you put ene on the end instead of ane. The only thing that's different here is you would technically want to tell where the double bond is taking place. Notice in your drawing here that these are both pentene, but the double bond is in a different place, so you would number your carbons 1, 2, 3, 4, 5. And this is 1, 2, 3, 4, 5. And then you would just say where the double bond starts. So this double bond here is coming off the first carbon, 1 pentene. This double bond is coming off the second carbon, 2 pentene, and we always use the lowest number. All right? So the naming for these is not too difficult. And you will actually have this information here on that reference sheet that I told you about. Cool? We can also substitute some of the legs of an alkene out with oxygen, nitrogen, chlorine, and we can make a different monomer so that when we chain together, we get different properties. These are some different alkenes. Notice there's still a double bond in the middle. You know, these are drawn a little different. But we've changed one of the legs, which is going to give us some differing properties. You don't need to know what those properties are. We just know that these are called substituted alkenes. They're monomers that produce different types of polymers. Last thing here is not last thing, we're getting there though. Alkynes. You can probably follow the pattern at this point. Alkynes are going to have a triple bond. Notice the formula. Carbon and then 2N minus 2. Why? Well, if I draw a triple bond between these two carbons, I only have one more hydrogen that each of them can take. And so because of that, we'd have 2 carbons, and then to get to the number of hydrogens, we'd double that to 4, and then we'd subtract 2, which gives us 2 hydrogens that'll fit there. So all alkanes, alkenes, alkynes all have different types of, they're very similar types of formulas, but they are different, and you kind of need to be paying attention. How do we name these? The same way as we name alkenes, but just now they're alkynes, they're triple bonds. So ethyne, propyne, things like that. Here's your pictures. Here's ethyne, propyne, 2-butyne. Okay, so look here. This is 1, 2, 3, 4, and so it's coming off the second. And you might ask yourself, well, why do ethyne and propyne, why don't they have a number? It's because they don't need one. If you only have 2 carbons, the triple bond's between them. And if you have 3 carbons, we know it's either going to be here or here, and it just depending on which end you're counting from, it's still off the first carbon, okay? So you don't really technically need that number there until you get into larger, more complicated. Don't need to worry about this, by the way. You're not going to see that, okay? You'll see this. One triple bond is all you'll see. You'll just need to put an "-ine" ending on the ending, count the carbons, choose the prefix, put the "-ine" ending on the end, and tell me which carbon that triple bond's coming off of, all right? Not too difficult, not too bad. So this is kind of a chart comparing all of them, right? Alkanes would only have single bonds, alkenes have double, and alkynes have triple bonds. Propane, propene, propyne. They all have 3 carbons. We just have double and triple bonds present and fewer number of hydrogens. Just to kind of review, this would be saturated. These would both be unsaturated because theoretically we could break those bonds and add hydrogen. Couple last things here. There are other builder molecules. So we've talked about alkenes, alkynes, and alkanes that are monomers that we can use to build these polymers, but there are others. One of them would be a cycloalkane, and it's exactly what it sounds like, cyclo. So it's an alkane that's literally in a circle or a ring structure. And the easiest, and basically when you would see one of these, I'd have to show you the picture, all right? All you'd need to know is count the carbons and put cyclo in the front. So this has 3 carbons, 1, 2, 3, cyclopropane. Okay, this has 4, 1, 2, 3, cyclobutane. 1, 2, 3, 4, 5, cyclopentane. But you'd have to know that it's a ring structure, and I would have to show you a picture. I would imagine you're going to see one of those pictures again on a quiz. Okay, it's going to happen. All right, but don't freak out. Just go back through your notes and say, okay, it's got this many carbons, and follow the pattern. Okay. Typically, if you have a ring structure like that and you have a double bond within that ring, that's an aromatic compound, and typically that means it's going to be volatile or evaporate pretty readily. Benzene is the most common, C6H6, but that double bond makes them volatile, and typically they have odors. So perfumes and dyes, they're typically aromatic compounds, kind of a circle, a ring structure with a double bond present. This is benzene, and this is sometimes how it's drawn, and it's just showing you, so each of these corners would be a carbon, and then they're showing you where the double bonds would take place. So you don't need to know a ton about cycloalkanes or aromatics. just be aware that they exist. You might see a question here or there on a quiz about them. That's all we wanted to do today. You do have an activity that will help you kind of walk through some naming of alkanes, alkenes, alkynes. No, you don't have to turn the activity in, but there's going to be stuff on the quiz that comes directly from those activities. So my advice to you would be do the activity ahead so that when you click on that quiz, you're ready to go. All right? You can have the activity right in front of you. That's fine, obviously, but that's how we're going to kind of end the week. So good job today. Be good to somebody today. We'll see you soon.